Okay, spring semester exam review, Algebra 1. We're on question 40. Find the area of a rectangle with sides that measure 2x minus 1 and 3x minus 5. Well, let's draw a rectangle so we can get a visual of what's going on. So one of the sides is 2x minus 1. One of the sides is 3x minus 5. They want us to find the area. How do you find the area? Length times width, right? So let's just multiply these guys together. That's all we're doing. So when we multiply these guys together, it looks like this. 2x minus 1 times 3x minus 5. It really is just like the problems from the previous video. That's all it is. Okay, so what do? I split the first one, 2x, and then the minus 1 can go over here. I write the second one twice. 3x minus 5, 3x minus 5. Okay? Okay, so I distribute here. The 2x goes to both of these. So 2x times 3x, 6x squared. 2x times a negative 5, negative 10x. Okay? Now this guy, negative 1 times 3x minus 3x. Negative 1 times negative 5 makes it positive 5. All right, take a look for like terms to combine. This guy's all by himself. He's going to be part of the answer. These guys are like terms. They're both negative, so I add them. I get negative 13x. This guy's by himself. He's on the end. 6x squared minus 13x plus 5 is my answer to number 40. Okay, let's take a look at 41. Factor out the greatest common factors. This is a little bit opposite of what we've been doing. All right. This, we're not distributing in, we're actually pulling out. Say it was already distributed in, and now we're working backwards and pulling out as much factor stuff as we can. Okay, so if you take a look at 41, you have 2x plus x. Or I'm sorry, 2x squared plus x. So what I'm going to do here, I have to pull out as much stuff that each of these terms have in common. Well, this guy doesn't have a 2. This guy does. I can't pull out a 2. They don't both have a 2. This guy has 2 x's. This guy has 1 x. So they each have at least 1 x. I could write it out longhand. 2 times x plus another x. If I pull out the x they have in common and put it over here, that gives me x on the outside. What do I have? What are my leftovers on the inside? I have 2x, not 2x squared anymore. I don't have anything here. But remember, there's always the invisible coefficient of 1. So I have a 1 left over. How do I know I got it right? Distribute back in to see if you get what you started with. X times 2x is 2x squared. X times 1 is x. So I do get 2x plus x. Now guys, a little hint for you with multiple choice tests. You could take your answer choices, distribute back in, and see if you get what you started with. It's not going to eliminate all the choices. It's not going to guarantee you get the right answer, because that doesn't tell you if they pulled out everything they can pull out. But you can probably get rid of some choices. So the answer to 41 is right here. Okay? 42. We have 12x to the 5th minus 36x. So 12 and 36, 12 can go into both 12 and 36, right? So I can pull out the 12. Let's pull out the 12. What are my leftovers if I pull out 12? Well, all I have left on the first term is x to the 5th. But I want to pull out some x's too, because this guy has 5 x's, this guy has 1. I can pull out 1x. After pulling out 12x, on the first term, all I have left is x to the 4th. After pulling out 12x from the second one, all I have left is minus 3 with no x's left. I distribute back in to make sure I did it correctly. 12x times x to the fourth is 12x to the fifth. That checks out. 12x times minus 3 is minus 36x. So it all checks out. So there's the answer to 42. 43, 15x minus 5y squared. Now notice with the variables, they don't have any variables in common. I can't pull out any variables. But 5 will go into both 15 and 5. So I can pull out the 5. So I pull out the 5. When I pull 5 out of 15, what factor do I have left? I have 3. And the x stays as well because I couldn't pull out the x. When I pull out 5 from negative 5y squared, all I have left is the negative y squared. So that's what I get from there. When I distribute back in, I get 15x minus 5y squared. So I get back to where I started, so I know this is right. Okay, that's question 43. Questions 44 through 49. Factor each expression completely. Tell you what, we'll do that on another video because that's a whole different concept.